Derivative means slope. Very good. Integral means area. Okay, so we're going to review our first part of our fundamental theorem. This is the one we've done before. Integral of a derivative. It is area under a curve. And so it is integral a to b. Oh, we literally just talked about this going over the multiple choice that we just did. If you have f prime inside the integral, when you do the antiderivative, that takes you back to just f of x, and it is upper boundary minus lower boundary. That is the fundamental theorem of calculus. It's upper boundary minus lower boundary gives you the area. If you look back at your notes the first time I taught this, they use a capital F and a lowercase f. Does anyone slightly remember that? Like, I don't like it written that way, though, because that confuses me. Like, one is capital and one is lowercase. I like it written this way, so I wrote it the way that I like it. So this is the second part of the fundamental theorem of calculus, derivative of an integral. Derivative is a rate. This is the rate at which the area is changing. And there's three kind of levels to this. So I have space to write three different things. Sorry, we'll have to persevere. So these are all going to say d dx out front of them. That's instructions. That means take a derivative with respect to x. So d dx, integral a to b, f of t dt. And if you're like, can I change those t's to x's? No, I'm sorry, because there's going to be an x in the problem as well. So there's going to be x's and there's going to be t's. All right, so let me cover this up real quick. If you did an antiderivative and then did upper boundary minus lower boundary, you would get a number, right? That represents the area. What's the derivative of just a number? Nothing, 0. So if both of your boundaries are just numbers, you get 0, because the derivative of a constant is 0. Here's the second kind of level to this. And so what you'll notice is I made one of the boundaries x. So it's a variable now. So all you do is you take x and you plug it in for t. And you just get f of x. The reason why that works is a derivative and an integral cancel each other out, okay? Basically, the only way you can mess this up is by doing anything. Don't put a plus c. Don't take a derivative. Don't take an antiderivative. Just plug in x, cool? Now, if the boundaries are reversed and x is the lower one, what do we do when we reverse the boundaries? We do what? Negate it. So it would be negative f of x. Do you get what I'm saying? If you flip the boundaries, it's the opposite. Okay, head's nodding. I'll take it. All right, and then the last sort of like level to this, instead of x by itself, if you have another function, so instead of just x, it's like x cubed or square root of x or sine of x. Like there's another function there. You still just take that and plug it in. So you take this g of x, like the whole thing, plug it in for t. But what derivative rule do you need when there's like guts of a problem? Good. So you chain on g prime. I usually write that part first because otherwise I'm worried I'm going to forget it. But yeah, basically, if you do anything is where you're going to mess up. Basically, just don't do anything. So looking at this first one, all you're going to do is take x and plug it in for t. So your answer is x squared plus 4x minus 7. Okay? For this one, all you're going to do is plug in x, but you have to negate the whole thing. So I would suggest putting a negative and putting parentheses. We'll have to distribute the negative sign. But just plug in x. So x squared minus x. And then if you distribute the negative sign, it'll give you that. For this one, do you see how it's not just x? Do you see how it's 5x? There's a chain rule. You have to chain on the derivative of 5x, which is just 5. And I usually put that first so that I don't forget it. But then you just take 5x and plug it in for t. So e to the 5x. I'm going to pause there for a second. Do you get why this 5 here, we ignored it, and this 3 here, we ignored it, and the 7 here, we ignored it? Why did we get to just ignore those? Constants. The derivative of a constant, 0. It could be 400 billion. We would still ignore it. All right, how about this one? Good. You just plug in x. Why is it negative? Below. It's upper boundary minus lower boundary. It's when you subtract the lower boundary. 0 minus sine of x is essentially what we did there. All right, how about this one? 0. They're both constants. Derivative of a constant is 0. This one is going to involve a chain rule. I suggest putting it first. The derivative of x cubed is 3x squared. And then you just take x cubed and plug it in. It'll look like that. I'm sorry, did I get the quick, or did you get it? Okay. For this one, do you see how it's not just x? There's a chain rule. Derivative of x squared is 2x, and it's negative because it's the lower boundary. And then you just take x squared and plug it in. So x squared squared, the x to the 4th, and then plus 5x squared. You could distribute the negative 2x if you want to. I'm fine with that answer too. It's fine. It's whatever. Now, what do you notice about this one? Okay, that means you have to do upper boundary minus lower boundary. You don't get to ignore one of them because neither one of them is a constant. Okay, but you can do algebra 1. It's fine. Plug in x plus 3. It'll be 2x plus 3 minus 5. That's the upper boundary. Minus, and I would maybe just like put some parentheses there. Just plug in x. So it would be 2x minus 5. And then you're just going to do the algebra, distribute and combine like terms. So if you distribute that 2 through the first one, good, 2x plus 6 minus 5. And then distribute the negative, it'll be minus 2x plus 5. And then what do you notice happens? Yeah, like the 2x's cancel and 5's cancel. And the answer is 6, which is pretty cool. All right, these last two. Same thing that we were doing, fundamental theorem of calculus, it's just written with words, all right? Ignoring all this, I'm gonna go to the part that it says to find, because lots of times they shove too much information in your face and you have to just be like, all right, what do they want from me? Do you see f of 6 minus f of 4? Yes, I want you to think fundamental theorem of calculus. So you would set it up integral 4 to 6. And what goes inside there is the derivative. And then you'd be like, oh my gosh, they gave me f prime. So 2t plus 1 is what goes in there. And then we're going to work it out. Now, when I taught this with my other class, they were like, oh, it's 0. I get why that happened. These are both just numbers. And they were thinking of what we just did on the other side of the paper. But do you see a d dx out front? No, we're not taking a derivative. We're going to actually work this out. So antiderivative of 2t. Yeah, t squared plus antiderivative of just 1. It's t. Yeah, I know, I'm sorry. If you said x, you're right. All right, such that 4 to 6, and then we're going to work it out. So if you plug in 6 squared, 36 plus 6, good. Perfect. And then if you plug in 4, 16 plus 4 is 20, so 22. All right, I'm going to ignore all of this. What they're trying to do is confuse you. Don't let them. Go to this find part. Find g of 7 minus g of 2. So it would be integral, what? 2 to 7. And what goes inside of there is the derivative. So I'm going to actually just write g prime for a second so that we can, or it should be t, I'm sorry. If you're all done, you can just leave that there. I'll grab it. All right. So that means they have to have given you G prime in some capacity, which they did. It's right here. It's 5 minus t times f of t. And what's f of t? Because they have to have given you that in some capacity. Yeah, the first there, right? 3t squared minus 4t cubed. I didn't make up this problem. Guess where I got it from? Classroom. Okay. Now we're going to use our calculator for that one. Do you remember how to type an integral? Math 9, Math 8 and Math 9 are your best friends, all right? I'm going to do 2 to 7. I know it says t, but I'm going to type x just because I have an x button, so that's easier. There you go. As long as you don't type it wrong. I do not love button pushing because if you hit one button wrong, it's going to be wrong, but you know, something you got to fight through.